All right, so for the last part of the week, we're going to kind of step away from conic sections. Okay, we're done with that. And we're going to look at solving systems of equations. So just as a reminder, when you're solving a system of equations, that means you have an equation that has two or more variables. So you've got two or more variables you're trying to solve for, and you have two or more equations. What's the limit? There is no limit. You could have 50 variables to solve for. We're not going to go that crazy, but we'll start out with some systems with two variables with two equations, and then eventually we're going to get into three variables with three equations. Some of the methods that I'm going to show you work great when you only have two variables. Okay, they're really, really good for that. As you start to get more and more variables, it gets more complicated. So out of all the methods, I'm going to show you one method that works well all the time. It doesn't matter if you're solving for 2 variables or 200. The method I'm showing you would give you a process to do it. One way to solve systems is graphing. Graphing is okay when you only have 2, because what happens when you graph is you end up drawing 2 lines, and you find where they cross. Well, if you start to get into 3 variables, now you'd have to be drawing in 3D. Okay, drawing in 3D, not that easy. So sketching is not a method that works well when things get more complicated. So we're not going to really do a lot with sketching. Okay, so for the first one, I don't want to solve the problem. I just want to set it up. Okay? There's really nothing I need to explain. I think we should be able to figure it out. It says find the length and width of a rectangle. So there's your 2 variables, length and width. And I'm giving you a couple criteria. The perimeter is 100, and the area is 300. Now, if I only told you one of those things, you couldn't solve it. Like if I just said to you, tell me a rectangle with a perimeter of 100, everybody in here could come up with a different answer. But the fact that the perimeter has to be 100 and the area is 300, that's going to limit it to not as many answers. Okay. All right. So first thing we should probably figure out is the 2 equations we need. Let's start with area. What's the formula for area of a rectangle? Yep.
It's base times height.
Yeah, base times height or length times width, same thing. So area, I'm just going to call it length and width because our problem uses length and width. Okay, so I'll fill in what we know in a second. Out of A, L, and W, we already know one of them. And what about the formula for perimeter? What's the perimeter of a rectangle? Yeah, it's the length plus the width times 2, because you have length, width, width. So you have 2L and 2W. So you can write it as 2L plus 2W, or you can do length plus width times 2. It doesn't matter. Okay. So let's fill in the one on the left. Caitlin, what do I know out of the A, the L, and the W? Which one do I know?
You know the area?
And the area is how much?
300.
So 300 equals L times W. L times W. It's one of my equations. And Ezekiel, for the next formula, which variable do I know? Perimeter, and how much is that? 100. Okay, so as far as setting up the system, we're done. Okay, that's all you have to do to set it up. Okay, on a test, you would have to know the formula for area of a rectangle. Okay, I wouldn't give you anything like area of an octagon. That's not as common, but area of a triangle, rectangle, things like that, you should know those. Okay. Questions on how we set up the 2 equations? So there's a couple different methods you can use when you're solving systems. We're going to focus on substitution and elimination. Both methods work. One of these methods is a little bit better to use when things start getting more complicated. But if you have a relatively simple problem like this one, you could try to figure it out with either method. All right, before I show you or kind of describe what substitution is, anybody remember it from Algebra 1? Can you kind of explain to me how substitution works? Yeah?
You get one equation with the variable by itself and then plug it into the other equation.
Yeah, so you're going to get the variable by itself in one equation and then plug that into the second equation. That's pretty much exactly what I'm going to write. So to use substitution, pick an equation and solve it for a variable. So in our problem, you have 4 choices at this step. You could pick equation, let's call this 1 and 2. You could solve equation 1 for L. You could solve equation 1 for W. You could solve equation 2 for L or equation 2 for W. Okay. I have a preference of which equation I would pick, but we'll go through that in a second. And then once you pick an equation, solve it for a variable, you're going to take that and plug it into the other equation. And then simplify. Once you do step 2, you should now know one of your answers. So if you're solving for L and W, depending on how you did step 1, you're going to know one of the 2. Once you get an answer for step 2, you take that answer, you plug it back in. Doesn't matter which equation. You plug it back into either equation and then get the other variable. Okay, so substitution, it's kind of one of those things where it's really wordy to describe it. It's not as hard to just do it. Okay, so we'll take the problem that we set up and we'll solve that. Any general questions on the steps that I wrote down? Okay. Substitution is a method that works fine when you have 2 variables. It gets kind of a pain when you have more than 2. It can work, but it's not as easy. So when we start to get beyond 2 variables, I'm going to show you a different method. Okay, but let's try this one first. So we're going to have the steps. Okay, so let's take, and I want to use the letters we had before. So we have 2L and 2W and L times W. Does it really matter what letters I use? No, they just represent something. But if I want to connect it with the first problem we did, I'll stick with L and W. Okay. Equation 1, equation 2. Do you think it would be easier to solve for L or W in equation 1 or equation 2? 2. If you solve for L or W in equation 2, you only have to do one thing. If you want to do it in equation 1, you can, but you're going to have to do more than one thing. So let's use equation 2. Michael, do you want to get L or W by itself?
L.
Yeah, it doesn't matter. It's pretty much going to be the exact same steps. So if you get L by itself, how would you move the W to the other side? Divide by W. Okay. So there's our formula for L. It's 300 divided by W. Okay. And now, Wyatt, what am I going to do with that 300 divided by W?
Plug it into the first equation.
For which letter?
No.
Exactly. Yep. So we're going to take what we solved for L, plug it back into the first equation, and see what happens. So we've got 2 times 300 over W plus 2W equals 100. Okay. Simplify 2 times 300 and get 600. And now, what I don't like about the problem is having a variable in the bottom of a fraction. So what could I do? But I'd have to do it in 3 spots to get rid of that W in the bottom.
Wait, wouldn't it be 600 over 2W? If it's 2 outside of the parentheses?
So you're multiplying 2 over 1 times 300 over W?
Never mind.
Yep, you could write it that way if that's clearer. Okay, so what could I do to get rid of that W in the bottom? Yeah, multiply everything by W. Now, when you multiply by a letter, you have to be careful because you're not allowed to multiply both sides of an equation by 0. And we don't know what W is right now, but I guarantee you it's not 0. Now, how come I know W can't be 0?
If you did like times 0, the area would be 0.
Yeah, if your width was 0, you wouldn't have a rectangle. You'd have like a straight line. So W can't be 0, so it's OK to multiply everything by W. So I get 600. And Matt, what's 2W times W? Matt. Matt?
He's gone.
Matt. Hi. Hey. Welcome. What's 2W times W?
2W squared.
2W squared. Good. All right. And the last part, we still have 100 times W. That's just 100W. Okay, it's not written the way we normally would write it, but what kind of equation is that? You're off the hook. You're good. You don't have to give me more answers until I call on you again. Yeah.
Quadratic formula.
That's a quadratic equation. Okay. So quadratic equation. First step to solve it is get everything on one side. I would put everything on the left. Okay. And I'm going to put it in order. So 2W squared minus 100W plus 600 equals 0. Now, this isn't necessary, but if you want to make the numbers smaller, what could you divide everything by? 2. To me, it just makes the numbers a little easier to work with. W squared minus 50W plus 300 equals 0. Okay, now we could try to factor that. We're looking for 2 numbers that multiply to give me 300 and subtract to give me 50. 300 is kind of a big number, so let's just use quadratic formula and see what we get. No, actually, I'll let you do the rest. So we get negative b plus or minus, what comes next? Square root of b squared minus 4 a c. Yep, all divided by 2a. Okay, so let's see what we get. 50 plus or minus, what's 4 times 300? 1200. What's 2500 minus 1200? 1300. So the square root of 1300 is not a nice number, so chances are this would not factor nicely. We're going to get a decimal. And remember, we're solving for the width. Okay, so let's type it in, see what we get. 50 plus square root of 1300. Okay, I'm just going to do the top first. And divide by 2. So we get 43.03. Now, the plus or minus means that there could be another answer. So I did 50 plus the square root of 1300. Let's do 50 minus the square root of 1300. 50 minus square root 1300 and divide by 2. There is a second answer. The width is 6.97. So let's call this my first answer. And let's call this one my second. So we're finding a rectangle, and I've got the width. What else do I need? I need the length. So let's find the first length and the second length. Any questions on how I got those two widths? Just a quadratic formula. Okay. Let's start with the 43.03. Let's go back up. If I have a width of 43.03, how can I get the length? Yeah?
You can plug it into the varied one over here, and then just divide the other lengths.
Yeah. So take 300 and divide by 43.03, and that gives you the length. 43.03. 6.97. Okay. 6.97. All right. My other width is 6.97. So let's go back up and do 300 divided by 6.97. I get 40, well, because of rounding, I get 43.04. Basically the same thing. So if you're talking about a rectangle, what's the difference between those two answers? There is technically a difference. It's rotated. One of the problems, you're looking at the rectangle this way. The other problem, you're looking at it that way. Are they the same rectangle? Yep. But just one of them, you're looking at height as the tall side versus the height as the short side. Okay. Any questions on that? So those are your two answers. Okay. Not every problem we solve is going to come out to be quadratic. This one did, but it won't get any worse than quadratic. Okay. This is just a basic linear problem, so you're not going to need quadratic formula at all. Okay, so let's solve it with substitution. Which equation should I pick? Equation 1 or equation 2? 1. Yeah, definitely equation 1. And what letter should I solve it for? Y. Yep. Y is the easiest thing to get by itself. Okay. Anybody tell me if I get y by itself in equation 1, what will it equal?
2x minus 5. Or 5 minus 2x.
5 minus 2x. Yep. Okay, so I got 5 minus 2x. Curtis, what do I do with 5 minus 2x?
Substitute into 2.
And what letter in equation 2?
To 2y.
To the y. Yep, so plug it in right there. Now, when I plug it in for y, I want to be careful because I should put parentheses around it. Why did I do that? Because if I forget the parentheses, we're going to
You have to distribute.
we have to distribute. So this is 2 times everything that you replace y with. Okay, so distribute. So you get 3x plus 10 minus 4x. Let's combine the x's. How about, Dave, what's 3x minus 4x?
3x minus 4x,
Negative 1x. And at the same time, let's put the 10 on the other side. 2 minus 10 is negative 8. So Kelvin, what's x?
X will equal E8.
Yep. So x is 8.
Good job.
Don't forget when you're solving a system that you've got to go back and find the other line. So Colleen, how would I get y?
Substitute in like for the x.
Yeah. And which equation would you use? Equation 1, 2, or the one that I wrote in red? Could use any of them.
1 because it looks easier.
Okay, so you could use equation 1, the one that's in black. Anyone think there's anything else that's even easier to plug into there? Yep.
The one you wrote in red.
Yeah, the one I wrote in red because y is already by itself. So y is 5 minus 2x.
Oh, that one in red. I thought you meant like the other one, like the
Oh,
one you
it's-
wrote like right there, and I was like, that's not.
Yeah, I got it. Yeah. But if you did the one in black, that's fine too. Okay. So y equals 5 minus 2x. And 5 minus 16 gives me negative 11. Yep. Okay, so there's a nice simple linear system solving with substitution. Questions on that one? So, if we were to get these in y equals mx plus b form and type them into the calculator, that's the coordinates where they would cross. 8, comma, negative 11. They would make an X shape. All right, so the next method, elimination. Okay, elimination is a little different. So the goal with elimination is to first line everything up in columns, your x's, your y's, and your numbers. And then you look at the numbers in front of the x's, and you look at the numbers in front of the y's. And you try to make them opposites, like 6 and negative 6, or 2 and negative 2. Okay? Try to make those two numbers opposites, and what happens is they cancel out. So you're going to add the two equations together to try to get one variable to disappear right away. And this word linear combinations means you might have to multiply an equation by a number first. Okay? So if I was going to do elimination on this problem and I wanted to get rid of the y's, I would multiply this top equation by negative 2. Okay? That's going to change the x. It's going to change the number on the other side. But the most important thing it's going to change is it would make that top number a negative 2 and the bottom one is a positive 2. And they cancel each other out. It'd be a little harder to get rid of the x's. If I wanted to get rid of the x's, I would have to make one of them a 6 and the other one a negative 6. So you could multiply the top equation by like 3 and the bottom equation by negative 2. And that would make your x's cancel. Try to cancel the one that involves the least amount of work. So we'll just think of it that way. You're trying to get the numbers in front of one of the variables to be opposites. And I just said that. So it might be necessary to multiply one of the equations by a constant. Try not to multiply by fractions. You can, but it's going to make life harder. So try to multiply by numbers that are not fractions. Any questions on those steps? Okay, in Algebra 1, when I teach elimination, we spend a lot more time on it, but you've done it. It's probably your third or fourth time seeing it, so we won't go over it forever. All right. So we've got 2x plus 3y equals 5. And negative 3x plus 5y equals 21. It's our choice if we want to try to make the x's opposite or the y's. So what letter do you want to try and get rid of here? X's. Okay? So we're going to have to multiply the top equation by something and the bottom equation by something to make these two numbers opposites. Did anybody see what I could multiply the top equation by? 3? Okay. So I'm just going to put a 3 on the outside. And what could I multiply the bottom one by? 2. Okay. Let's do that out and see what we have. So we're going to get 6x plus 9y equals 15. And Evan, can you tell me what I would get for the bottom one?
Negative 6x plus 10y equals 63. I mean 40.
42. Okay, so now if we look, we did it perfect. Positive 6, negative 6. You're going to add everything up vertically. That's 0. You don't even need to write it. Okay, that's 0x. So, you know what? I'm not even going to write it. 9y plus 10y is 19y. And 15 and 42 gives me 57. Divide by 19. And there's your answer for y. What's 57 divided by 19?
Can't do it off the top of your head.
Yeah, you can.
Just figured.
3.
What?
Y equals 3.
Teacher's
Okay. Question on how we just got y? Why is elimination here maybe a little easier than substitution? Because you could do substitution. But it's not really set up for substitution. How come?
Well, there's not a lot of numbers next to the x's and y's, and they're all high, so.
There's a lot of numbers next to the x's and y's. So to try to get an x or a y by itself is not the best way to do it. Elimination, we avoided fractions for the whole problem. Even the final answer is not a fraction. Okay. All right, so now we take y, plug it back in. Which equation looks easier, top or bottom? Yeah, top. It's got smaller numbers. They're all positive. That's always good. So 2x plus 3y equals 5. 2x plus 9 equals 5. And if you keep solving it, eventually you'll get x equals 4. Sorry. I messed that up. Negative 2. Okay. Any question on that one? Okay. So there's 3 things that can happen when you solve a system with 2 variables. One of the things that can happen has just happened here, and basically the same thing happened in the problem before it. Okay. Think when you draw 2 lines. What can happen when you draw 2 lines? They could intersect. They could look like this. They intersect and they cross exactly in one spot. What else could happen if you draw 2 lines?
Parallel.
It could be parallel. If they're parallel, they never cross, and that means you're solving something with no solution. What's the third thing that could happen? Well, perpendicular would just be one solution. They would cross exactly one time. They could be exactly the same line. You get one line right on top of another line, and they cross everywhere. So there's an infinite number of solutions. Those are the 3 things that can happen when you're solving a system. Thank you. Okay, I usually mention what would happen if you draw 2 lines, because that kind of jogs people's memory of the 3 things that can happen. They cross, parallel, same line. Okay, so keep those three ideas in mind. Let's solve this one. Let's decide first, substitution or elimination?
Elimination.
Yeah, elimination, you've got numbers next to all the letters. It's not easy to solve one of them. So now we have to decide, what do we want to eliminate? X or Y?
Why?
Y? Well, we'll see what happens.
Why?
Yeah, you get no.
Yeah.
So if we're going to eliminate Y, what would you have to multiply the top equation by? 3. Bottom equation, you don't have to touch it. So multiply this out. Make sure you do it to all 3 terms. 6x minus 9y equals 15. Now, look what happens in the bottom. What's 6x minus 6x?
0.
And then negative 9y plus 9y.
0.
So I get 0 on the left. I get 25 on the right.
Huh.
Does 0 equal 25?
No.
So what do you think that means?
No solution.
No solution. Okay. Don't write false. Some people write false. The answer is there is no answer. No solution. False. Okay, let's look at this one. Substitution or elimination? Yep.
I mean,
Well, yeah, elimination.
substitution,
I would-
substitution.
You could also do elimination because
both.
the x is not that hard to get by itself. But
And then
let's
you can do Y.
do
I
elimination.
guess elimination.
All right. So what would you multiply the top equation by? 2.
Wait, what? Oh, we're doing it.
We're going to do
I
elimination.
don't know what to do.
Okay, what do you get if you multiply the top by 2? 2x minus 6y equals negative 4.
No solution is
The bottom is 2x plus 6y equals 4.
no. Infinite solutions.
0 equals 0. Infinite solutions. Okay, so the 3 things, single solution, you get a single number for x, single number for y. No solution, you end up with a false statement. Infinite solution, you end up with 0 equals 0. Okay, a true statement.
So how come the first time we distributed both top and bottom?
This time we didn't have to because 3 is a multiple of
It's already the
6.
same? Oh, because if
Yeah.
it's multiple, you don't need to.
In this problem,
They're not.
2 and 3 aren't multiples of each other, and 3 and 5 are not either. All right, so last problem we'll look at is still an elimination, just with 3 variables. Okay, the idea here is you do the same thing you've been doing, you just have to do more of it. So you're going to have 3 equations, you're going to pick 2 of them, and you're going to eliminate one of the variables in those 2. Then, using those 2 equations, we're going to eliminate another variable. So we're going to start with 3. Then we're going to get it down to 2. Then we're going to get it down to just 1 variable. And by the time we do that, then you can solve for 1 variable. And once you have one of them, you just plug it back in, you can get a second one. And once you have 2 of them, you can plug those in and get a third one. So it's a little longer, but the process isn't any different. You just have to do it more times. Right, so I've got a couple of these to try. We'll see how many we need to do. Generally, I'm going to give you problems that work out nice on the test, so you're not going to have to worry about fractions. Okay, so if things start getting really messy and your numbers are crazy, probably take a step back and see if you made a mistake, because the answer's on most problems. are not going to have fractions. Okay, so let's take a look. Okay, so there's our system. So the top one is 2x plus 3y minus z equals -1. 3x minus 2y plus 2z equals 15. And x plus 4y minus 3z equals -8. 3 equations, 3 letters. Just so making them. Okay, so we have a lot of options. We have to pick 2 of those equations and eliminate one of the variables. So let's call them equations 1, 2, 3. What 2 equations do you want to work with first?
1 and 2.
1 and 2. Okay?
And get rid of z.
Let's get rid of z. I think that's a good option. So, what would we have to multiply? I think you only have to multiply equation 1 here.
By 2.
Let's multiply equation 1 by 2. So multiply that by 2. First, any question why we're going to multiply by 2? If you do that, look at what's going to happen to the z. And then look at the z in the equation 2. Okay, you don't have to copy over the second one here. I'm going to keep scrolling down, so I'm going to lose it if I don't copy it down. All right, what's 2 times 2x? 4x. 2 times 3y? And 2 times -z? And -1 times 2. -2. Now this is why I copied it down so I can still see it. 3x minus 2y plus 2z equals 15. Okay, add them up. 4x and 3x gives me 7x. 6y minus 2y? 4y. -2z plus 2z? 0. And -2 plus 15? 13. So now what you've just done, we'll call that equation 4, is you've created a new equation that only has 2 letters in it. Okay? We have to create one more equation with just 2 letters, and it has to be the same 2 letters we have right there. Okay? We already used equations 1 and 2. So we could use equations 1 and 3, 2 and 3, but we have to eliminate z one more time. What would be another way we could eliminate z? What equations? You could do 2 and 3. If you do 1 and 3, I think it's going to be a little easier because you're only going to have to multiply equation 1 by what?
3. -3.
-3. Okay. So I'll do that over here so I can kind of keep it on the screen. So we're going to take equation 1. And what did we just say to multiply by? -3. So we're doing the same thing we just did all over again. We're getting rid of z again, but we're using different equations this time. We're using 1 and which other one? 3. So I'm not going to copy 3 down. I can see it. I don't need to write it again. Let's just do this out first. What's 2x times -3? Yep. And -3 times 3y? -9y. -3 times -z?
3z.
3z. Positive, yep. And -3 times -1?
3.
3. And copy down the other equation. X plus 4y minus 3z equals negative 8. The z's are gone. Cameron, what do I get for my x's?
Negative 5.
Yep. 5x. Negative 9 plus 4.
Negative 5.
Negative 5y. And 3 plus negative 8.
Negative.
Negative what?
5.
Negative 5. Now, technically, we can use that equation the way it is, but we could make that equation even easier. What could you divide everything by if you want to?
Negative 5.
You could divide everything through by 5. Okay? Do people want me to just leave it the way it is or make it simpler? Okay, so make it simpler. So divide everything by negative 5. X plus y equals 1. Okay. Any question on how I got that? Divide by negative 5. Those cancel. Divide by negative 5. Those cancel. Those cancel. Okay. Let's call that my fifth equation. Okay. So it's a little bit longer, but you're just doing the same thing. Now, look at equation 5 and look at equation 4. What letter do they both have? Or letters? X and Y. So now, take those and do this just like the kind of problems we've been doing. Get rid of X or Y in one of them, and then we're about to get to the part where we're going to have all the answers. Okay? We've done more than half the problem already. Even though we don't know X or Y or Z yet, that's the hardest part, the first step. Now, what could you multiply that equation by to cancel either the X or the Y? Yeah, multiply by negative 4. So that's going to give me negative 4x minus 4y equals negative 4. And then copy down the one we had right below. 7x plus 4y equals 13. Y's are gone. Now we're going to know one of our variables in a second. What's negative 4x plus 7x? 3x. And what's negative 4 plus 13? 9. So what's x?
3.
3. Now we know x is 3. Well, we could take that and plug it into that equation right there, and then we're going to have y right away. So 3 plus y equals 1. What's y? Negative 2. So I told you, once we get the first answer, now they all come pretty quick. Now we have x and we have y. Plug them into any one of these originals to get z. Which one looks the easiest? 1. All right, so 2x. So we've got 2 times 3. 3y. So we've got 3 times negative 2. Minus z equals negative 1. 6 minus 6. That's gone. What's z equal? 1. So that's solving a system with 3 variables. Definitely longer than 2, but you have to do the process a couple times. Okay? So tomorrow I'll show you a little bit better system for solving something like this, a little more organized. Some people like this better, some people like what I'm going to show you tomorrow better. It's up to you which one you use on the test. Okay, so homework tonight is 541, 1 through 19 off. Okay, and this is not in the packet. This is back in the book.